centrifuges, well, twofold. They are capable of removing moisture or a lot of water, gross water. If you had hundreds of gallons of water in the system, you might be able to get to it with these. The difficulty is they're not going to touch an emulsion. Obviously, they're not going to do anything for dissolved water. The other challenge is maintenance. If you guys have maintenance operators who have to work on these, it's a nightmare. It's a couple man days to do a re-clean of these things. Pull all the buckets out, clean everything, put them back in, get the thing primed and running. So in terms of technology, I don't know if anyone's putting them in anymore. You know, 15-year-old plants have them. I don't know if anyone is still building a new plant with them. But they are running the challenge of operator difficulty and really not touching water in all its phases. Another technology, which we actually have quite a bit of experience in other industries, Beth will tell you that we do liquid-liquid separations as a major portion of our business. Very discrete separations. We can take 99 specific gravities of 0.99 out of 1.0. I mean, very easy, very discrete separations. People have been trying to use this, and for a number of years they have used coalescing type separators, or filter separators as they call them, for oils. They'll try and essentially grow the water droplets big enough that then a barrier media, Teflon type media, won't let them pass. Again, they have certain suitability for really gross volumes of water, but they've run into a new problem in the last few years, and that is as plants are moving to the group 2 base stocks, the polarity of that fluid really attracts water, and all of a sudden it's finding these coalescers are not functioning like they used to. I mean, we're hearing that from a lot of facilities, and our own lab's proven to ourselves that the separation that used to work on a basic mineral oil and water really efficiently doesn't do it at all on these new types of oils. So that kind of leads us to the third main technology. That's a beautiful picture from the 80s of a vacuum purifier. As Beth said, we do have some experience with these. We used to build them. We've stopped shortly after we started, actually, in the 80s. Vacuum purifiers have quite a bit of acceptance in the industry because they're the one thing that's out there that can deal with the dissolved moisture. They can deal with the emulsion and the dissolved moisture. The difficulty is they're very challenging to operate from most plant standpoints. They're expensive. They take a technician who's got a very strong core set of skills, and that person needs to be available to run it whenever you need it. The other challenge is if there's really gross amounts of water, they may have trouble keeping up. They can boil off a fair amount of water, but if it's hundreds of gallons, like in a major turbine upset, you can end up with so much foam forming through the vacuum tower that it actually starts foaming off the top, and now you've got oil going into vacuum pumps, you've got oil hitting the floor. So they're very complicated devices that take a good skill set to use, and quite frankly, we just say they're not operator friendly. So that's why we've originally steered away from them, and that's ultimately what led to the development of the Driflex technology. So Driflex is unique in that it's based on the core technology of it's essentially a moisture exchanger. So basically, multi-dry technology is another trade name for it. That's where the patents are filed under. But essentially, it's a moisture exchanger. And basically, what that's saying is similar to, everyone's familiar with the shell and tube heat exchanger, I think. Shell and tube heat exchanger, you got hot oil on the inside of the tubes. You're running a cool medium across the outside. You're pulling the heat out of the oil. This is doing the same thing, but we're doing it with moisture. In this case, you'll put a moisture exchanger. This is the internals of one unit. The oil flows down the inside of this tube bundle, which you can't, we'll send this around in a second. There's about 6,000 individual tubes in here. So it's like a heat exchanger in miniature. So you've got oil flowing down the inside of all these tubes. You then have dry air on the outside. We can actually extract the moisture from the oil through the membrane surface and into the air. So essentially we exchange, the mass transfer direction is essentially moisture out of the oil into the air and exhausted away. And I think that did say that there was a gradient there. If you think about it, the drier, the bigger the gradient from the moisture level of the oil to the dryness of the air, the greater the rate of exchange. All right, that's a big slide. So essentially, with the technology, it's one of the few that's actually capable of removing free emulsified as well as all of the dissolved moisture. we're seeing systems in transformers. I've seen 5 parts per million water. It was able to get incredibly dry systems. At the same time, we've designed a hardware that eliminates all the operator interfaces of a vacuum purifier. So you can get the dryness of some of those technologies without all the operator requirements. And we touched on this earlier, and we talked about what's happened now with these new Group 2 base stocks. We're indifferent to those. The technology works equally well, whether it's free water, emulsified water, or dissolved. You can remove it irregardless of the form. So, in detail, send this around so you can see how cool it was out there last night. So that's a typical we call it basically the internal bundle for the Driflex. Driflex systems will have anywhere from 1, 3, 7, 14 of those inside of one housing. Like I said, there's about 6,000 individual fibers in there. And basically this graphic represents just one of those fibers. And essentially what's happening, the oil's flowing down the inside of the fiber, basically goes in one end and out the other. We then take plant air, run it through another product we make, which is membrane air dryer, and we essentially take that plant air, we'll drop the dew point to at least a negative 40-degree dew point. So the air is essentially bone dry. That air is introduced, you'll see on each end there's a series of perimeter holes. That air comes in and it's essentially sweeping down the outside of the fiber. So you got oil on the inside of the fiber, air on the outside. The differential of moisture content between the air, which has none, and the oil, which has some, is the driving force. The membrane itself is designed to be completely impermeable to oil and very permeable to water. So water molecules right through, oil molecules that are stuck on the inside. So as you see, there's an O-ring on one end that essentially is separating the two parts of the air. Exactly, one way or the other. And
now your housing, do you replace the entire housing, the entire kit every time you...
if you ever needed to, yeah. The beauty is there's nothing, the only thing consumed in the dehydration is some plant air. So the membrane itself isn't picking anything up. It's not absorbing it. It's actually just allowing the water to transfer through.
The holes.
They're actually pretty big. The lumen's the idea of a membrane, several hundred microns. So by our world, that's a huge hole.
That's huge by our standards.
Well, yeah, we get big particles though, so I was just wondering how quickly we would plug.
Yeah,
Yeah, we would address that off skid,
Yeah.
and as you see this and on skid. So yes, we would. There's some analysis that goes on with each application to make sure that the big chunks are out of the way before they hit the membrane.
Little chunks don't mess up with the interface of the...
Yeah, I mean, we typically, the onboard filtration is typically between 1 and 6 micron. So it's
So you most likely have a pre-filled.
so you got a pre-filled.
we do.
Right.
But essentially, yeah, obviously, yeah, if you're under a 20 micron or a 50 micron particle, it's not going to hang up in there. It will go down. There is a concern that if you start getting particles damaging the surface, you're going to interfere with the moisture exchange rates. And part of that's why we've built in a pre-filter right into the skid. So essentially, we like to call it a very simple, very elegant solution that we've taken all the complexity of things like vacuum purifiers and centrifuges out, developed a very, well, now it appears simple, very technical dehydration contactor that goes in the middle, and that drives the whole process. So we've got a cutaway view of how the system looks here. I think I already covered all these. One thing that is interesting, yeah, we talked about the saturation point a little bit. There is no concern with that with us. Essentially, the greater the differential between the moisture in the air and the moisture in the oil, the greater the rate of exchange. And that's why if you have a system that upsets periodically, like the example I gave of that other power plant, that every time they change load, this thing will take out when that thing loaded up like that, the rate of water removal is 10 times higher than it is when it gets down to 100 ppm again. So it goes up with the concentration. Diffusion, yes, that's all it is. So, basically in operation, the unit typically is installed as a kidney loop or a slipstream to the reservoir. We'll take oil right off the bottom drain, that's fine. So essentially we'll have, the skid has its own pump,